Our speaker tonight, John O'Shea, is the curator of Great Lakes Archaeology at the University of Michigan Museum of Anthropological Archaeology and professor in the Department of Anthropology. He has a BA in anthropology from the University of Nebraska, a diploma in prehistoric archaeology from Oxford University, and received his PhD in prehistoric archaeology from Cambridge University. So he's certainly well qualified to present a wonderful lecture to us tonight. His topic is going to be Stone Lines and Caribou Hunters, identifying ancient hunting structures beneath the Great Lakes. And I'd like you all to please welcome Dr. John O'Shea.
And I've been watching people use this controller all day. So, thank you for inviting me here. I've been really enjoying listening to the talks today. I've learned some interesting things, and I think I have some things that hopefully will be interesting to you. Some of the challenges that we face dealing with rock kinds of structures, and sometimes convincing people that they're real. And other times, convincing ourselves that we're being properly skeptical about our materials. Anyway, so I'd like to start out and talk about hunter-gatherers and hunting structures. Now, one of the things I've actually noticed in listening to the talks here today is that a lot of the things that I deal with actually are utilitarian things. I'm dealing about hunter-gatherers, I'm talking about the kinds of structures they build basically for subsistence activities and for housing. And I'm not really dealing with the kind of ritual problems that you are with some of your potentially ancient structures. And so that's going to be a little bit of a difference. Basically, hunter-gatherers construct hunting features basically to increase the predictability and the certainty that they're going to have sufficiency. And this is what's known in the anthropological literature now as niche construction, where they're modifying the environment to improve that. And that may be through hunting blinds and structures like I'm going to talk about. It may be things like fishing weirs. They're common globally. They take many forms. And they have a lot of different effects that knock on in terms of how hunter-gatherers organize themselves. Now, what makes them, one of the characteristics of these is, first of all, they take advantage of the natural features. So if you have a natural gorge, if you have an esker that forms a barrier or something, the hunter-gatherers are going to take advantage of this. They're going to pay a lot of attention to the nature of the species that they're hunting, in our case today, caribou. They may use wood, they may use stone, but what they're going to do is they're not going to go to more effort than they have to. Even higher. Okay, better? Anyway, they're going to take advantage of what's there. They're not going to work harder than they have to, but also these things may grow over time because they are a kind of permanent structure on the landscape, and so they will continue to be used. They'll be elaborated. They may change over time as they're used. Now, okay, we have everything but sound. The big problem, I don't think we can do that. The big problem, those of you who are old enough, which is virtually everybody in this audience almost, to remember David Letterman, he used to have a routine that was, is it anything? And I copied it out, but we're not playing the video or the audio. But also this question, is it anything, is something that comes up a lot when we're dealing with stone structures. Is it something or is it a natural thing? And fortunately for us, we have some ethnographic and historical examples. So what you can see here is a very elaborate drive line. This is an aerial photo. This is on Victoria Island in the Arctic. Here's another little hunting structure. So this is really a big one. It has a big, tall inukshuk in the middle, which is a kind of stone construction that looks something like a person, perhaps. And here's what it looks like on the ground. Is it something? Is it anything? This is that drive line. This is actually a hunting blind and it actually has a fireplace there. You can see where the charcoal was. This was still in use. You see also a glaciated landscape. This is very different than your landforms. This is flat as a pancake by the ice, a lot of water, but that's what a hunting structure looks like. And we'll talk a little bit about caribou and why this works. Here's some more examples. These are from Andrew Stewart up in Toronto. You can see these are more cairn lines that are driving animals. Here's another drive line. And then you have different kinds of caches, hunting blinds, tent circles. All of these, you could look at it and you could agree, yeah, these are real. You could say maybe they're not real. In this case, they either had ethnographic informants saying they were real, or they had what is in fact the gold standard of determining that something is a real human construction, and that is artifacts. And these are artifacts that derive from those features you were just looking at. And some of these are quite interesting. There's a Northwest Coast dragon side plate on a flintlock. You see there's the octagonal barrel. Here's a Hudson Bay trading post coin. Here's an artifact, actually a spear point. If you look at it, it has a fracture at the tip, which is typical when a tool has been used and broken during use and then discarded. And this is actually a fireplace. This is a worked bone tool. So if you found any of these in direct associations with one of your stone structures, you pretty much have convinced the skeptics that what you have is a real thing. But what if you don't have artifacts? And certainly in our case, with hunting architecture, often hunters try to keep hunting areas really clean. They don't leave animal bones there. They may not do the primary butchering in that place, so you may not find artifacts. So how do you evaluate? How do you decide whether it's likely to be something or just how do you maintain proper skepticism? Well, one thing is you look to see if it really differs from other natural features around you. Does it look out of place? In our case, we're worried a lot about stone features that are formed by ice or by wave action. Up here, it's a little different. We look at the location and orientation. Does it make sense in terms of the animal behavior? And do we find more than one of them? Are they replicated? Are they part of larger structures? All of these things are kind of that evidence you start to assemble to convince yourself that, yeah, maybe it really is real. So one of the reasons I think I got invited was because we've been doing this work underwater. And because we're doing it underwater, we can eliminate some of the variables. We don't have to worry about colonial Americans creating our hunting structures underwater. So if we find hunting structures, if we find stone constructions, there's much more certainty that they were in fact created in ancient times. And in fact, that time window is another one of the variables we're going to be able to reduce for you. So just a word about underwater archaeology. Most people, when they think of underwater archaeology, think of shipwrecks. And certainly the Great Lakes, with their cold, fresh water, preserve shipwrecks really well. But there's also submerged sites where we're actually looking at prehistoric sites, ancient sites, that for one reason or another are now underwater. And as you can imagine, these present, even though we use many of the same techniques for analysis, the approaches are very, very different. With a shipwreck is essentially a historical problem. We know there was a boat and it got lost. So we can search for that boat and we can use historical records to try to estimate where that boat is. Now, where the boat landed on the bottom is kind of immaterial. It wasn't supposed to end up there. It just did, right? On the other hand, if we're trying to look at hunter-gatherer sites underwater on submerged landscapes, we don't know that there's a site there. And we know that the sites that they create tend to be kind of small, low density. And so we have to, that environment that's represented by the bottom is probably the single most critical clue we have to where things are likely to be located if they're there. So the first step that we have to do is decide what that environment looked like 10,000 years ago when this was dry land. So let me turn then to the Holocene Great Lakes and the archaeology of the Alpena-Amberley Ridge. As you may know, the Laurentide Great Lakes were created basically by the advancing Wisconsin ice sheets. They gouged the basins of the lakes out of bedrock. And then as the ice withdraws, as the glaciers melt, that meltwater fills these basins. This is effectively the sequence. Now, what makes this tricky is it seems like it ought to be straightforward. As the glacier melts, more water goes into the basin. But actually, there's a second factor that's operating here, and that is that weight of ice, that 1 to 2 mile thickness of ice, weighs a lot. And when that's removed from the Earth's surface actually rebounds. So at one and the same time, we have water levels, we have water, we have the lake levels rising. On the other hand, we have the land rising, and they don't do this in a linear fashion. As a result, we get this weird oscillation where the initial Algonquin Great Lakes, known as Lake Algonquin, is really quite substantial. It's more than 100 meters higher than the modern lake level. Modern Lake Michigan and Lake Huron are a single lake at this point. We then get an oscillation known as Lake Stanley when the lake levels drop more than 100 meters. They're 100 meters lower than they are today. And at that point, as this kind of shows, Lake Michigan and Lake Huron basins are separated. Eventually you get a river that forms between them. And the lakes in the Lake Huron basin where we're working actually become 3 separate lakes. So the water levels are much lower. This kind of shows you kind of the diagram of how those lake levels are oscillating. So this is a bathymetry map of Lake Huron, and essentially everything that's orange and orangey yellow is dry land during Lake Stanley. Lake Stanley's about 10,000 years ago to 7,500 years ago. And I've added in where the Alpena-Amberley Ridge actually runs. This is what it would have looked like. Let me orient you. You're north looking south. This is Saginaw Bay. Detroit's down here. That's Lake St. Clair. And everything that's green is modern land. Everything that's brown was land during Lake Stanley. That's more than, what did I say, 260,000 square hectares. A hectare is 2.4 acres. That's a ton of land that for about a 3,000 year period is available for human occupation, for plant and animal colonization. The Alpena-Amberley Ridge is this feature here. And this is kind of what the environment looks like. It turns out that a lot of this environmental information is really well preserved underwater. Things like pollen, testate amoeba. More recently, we've been finding peat, which we're testing for environmental DNA. And so we can get a pretty good idea of what this landscape looked like. And it looked pretty much like this. Again, you'll notice it's pretty flat. A lot of water, pods of spruce trees, and lots of kind of open ground. That's probably a pretty good image of what the Alpena-Amberley Ridge looked like 10,000 years ago. Now, the other piece of this puzzle is a really wonderful animal called the caribou. Caribou is a dandy creature. It has some really interesting behavioral quirks that are going to play into the story. But it's also pretty much an Arctic adapted cold weather kind of animal. It's found now only up in the Arctic. It's found in Alaska. The old world version is reindeer, which is a very closely related, not quite identical species. And they have an interesting story in terms of the Alpena-Amberley Ridge. And that is that the Alpena-Amberley Ridge, as you remember, as you saw, is a really narrow strip of land. And it's surrounded on both sides by very, very cold glacial meltwater. The ice front's only a short distance north of us. As a result, the Alpena-Amberley Ridge stays a near Arctic or subarctic kind of environment, even as the rest of the region is going through the middle Holocene and starting to warm up. So as a result, we get a persistence of Arctic-type vegetation. We get a persistence of these cold-adapted Pleistocene animals like caribou, and we see the persistence of human hunting technologies that are designed to go after these animals. And so this is why it's kind of called a refugium. It's a place where everything else is kind of warming up, but it's staying cold, and so it's a particularly appealing place for our caribou. This is kind of an illustration of that. This is a case where these aren't archaeological specimens, these are paleontological specimens. And what this chart is showing you is that you have a fair number of paleontological specimens of caribou back 13,000 years ago. And when the water comes back up, you get it. But in this time of Lake Stanley, in mainland dryland Michigan now, you don't find any caribou remains. And that's because the caribou were out under the lake. So this is a picture of an oil pipeline in Alaska. And if you recall, when they first built these pipelines, they had tremendous trouble. They diverted literally hundreds of thousands of caribou's annual migration. And the reason is because caribou follow lines. It's a kind of behavioral quirk that they have that both modern reindeer herders and ancient hunters took advantage of. Caribou will follow lines. There is a road being built in Alaska now that's called the Ambler Road. It runs east-west. It's about 200 miles long. And the National Park Service found with their collared caribou, when they're migrating from south to north, they migrate till they hit that road, and then they go east 200 miles, following the line of the road. They cross the road, come 200 miles back before heading on in their northern migration. They are just programmed to follow lines. So this is something that hunters can take advantage of. Even if you don't have lines drawn out, they'll make the lines. This is showing you, this is actually migrating across the tundra. Actually, they're going to cross ice over water out there. And you can see the scale of this. And the scale of the modern migrations are probably a factor of 10 less than we would have seen pre-contact. Lots of animals walking like this. And so, like I said, hunters understand this. And so they design various kinds of structures to intercept caribou when they're on these annual migrations. So this is actually a scrimshaw. This is a pipe from the village of Kotzebue in Alaska, north of the Arctic Circle. And it's actually showing you a depiction of caribou being kind of led into a kill zone, into a little thing. In this case, it's just made with brush. It's not made with rocks at all. But what's really curious about caribou is that you can create these lines and they will follow them. Now, it's not like out west where you stampede, panicked animals over a cliff. The lines are enough to suggest the direction the animals move, and then you can drive them or direct them into your predetermined kill zones. So armed with this, we can kind of predict what we ought to be finding out here, because the bottom of Lake Huron, just like this part of the world, is full of rocks. And that Alpena Amberley Ridge is so far offshore, it's 50 plus miles offshore. There's also no sedimentation there to bury things. So what you see out there is pretty much what was there the last time it was dry land. We worked primarily on 3 areas to begin with. We've recently linked up and done all that land in between. Again, the brown is what's dry land in Lake Stanley 10,000 years ago, and the green is what's modern land. Now this show is going to show you what it's like going to the bottom of Lake Huron. So that's a shallow stop tank. Those of you who dive, that's 100% oxygen there when you're coming back. And then this is the downline. So this is what the divers follow down to the bottom and they come back to the surface on. If we're using any tools we're using on this particular dive, it's attached to the bottom of this. This is a deep stop tank, which is at about 75 feet, and it has 50% oxygen. And the bottom of this line is about 135 feet. Into the abyss. So what you're going to start seeing now is the bottom, and the material that's white is just kind of a dense boulder clay. The material that's green is actually where there's zebra mussels, which are invasive, that have then had algae growing on top of them. But there's no sediment at all. And here at the bottom you have wreck reels, which the divers will then unspool as they go to do their jobs to make sure they can get back to this spot. But this gives you a little bit of an idea of the kind of visibility you have. This is, again, 135 feet. Everything is with natural light. And there you get a sense of the visibility you have. So not bad. You wouldn't object to that if you were in the Caribbean. I mean, that's not bad visibility. It's a little colder. So now I'm going to show you a couple side-by-side comparisons of some of the kinds of hunting features we find with comparisons of ethnographically known examples. So here's, back from Victoria Island, here's one of these V structures. Again, these aren't big walls. A caribou could step over these, but they don't. They just kind of follow them in. And here's a sonar image of one that we have under Lake Huron. We're going to talk more about this one right here, which is the dragon blind. But again, it's just kind of a thing to kind of mosey them along into kind of an area where you can have a predetermined kill area. You don't even have to have continuous rocks. You can have just sets of these standing rocks. So this is all it really takes. This is a river crossing where the animals would be coming across. This is where they're coming ashore. They have these kind of spaced out up the shoreline. Here's the equivalent that we have under Lake Huron. You might wonder why I didn't Photoshop out the cable from the ROV. And the reason I didn't is actually because I'm a really honest guy. And there are a whole line of these, and we actually pulled one over with the cable. So this is my penance. Again, here's a kind of thing where we have a setup where we have rock lines, just low lines leading to high ground where you have a series of hunting blinds. Here's what the typical hunting blind looks like. We call it a V structure. Each of these rocks is between 3 and 4 feet in diameter. And you just have five of them in a row. That's all the concealment you need. And so in that case, these kinds of structures are just lined up here kind of just beyond the military summit, so the animals don't really see them till they come up over the top, and you can see how these are funneling the animals to that spot. This is actually a tent ring, kind of rectangular. This is again one that Stewart recorded at the Kazan River, and here's an acoustic sonar image of a really very similar looking rectangular structure. I'm afraid to look and see if it meets these Pythagorean thirds we heard about earlier today. And then you have different kinds of structures. This is a caching site. These rocks are all, this is actually from a photogrammetry thing that we had to take a lower resolution still from. But you'll notice they're all propped up like this. So they create almost like an interior dome area for caching. This is a real classic campsite. There was a fire here. They used this big boulder basically to reflect the heat. So again, in this case, this is probably a campsite, but to the degree it was modified at all, it was moving rocks out of the way rather than adding rocks to it. Okay, here's that blind site I was telling you again. It actually had the fragment of a cervid tooth in it. This is the Michigan State underwater archaeologist, Wayne Lasardi. He was a great skeptic of these sites until we made him dive on it, and now he's convinced he's found inscriptions on them. But one of the things that I think is interesting about this is this white surface is actually dead algae. And when you scrape the white stuff off, you find these are actually old red sandstone boulders. Now, old red sandstone comes off the Canadian Shield. Now, I'm not saying anybody carried these from Canada, but it really does kind of look like the hunters were maybe a little selective in terms of which rocks they chose to pick. And that was kind of interesting. Pardon me? That's the tooth of like a caribou. Then we have more complex hunting structures. This is called scanning sonar. So basically the head rotates through 360 degrees to help you image something. This is actually National Geographic divers diving there. But you basically have two arms to this funnel, and the animals then kind of come into this, and then you have these more scattered boulders out here. They're all in a line, although it's not a tight line, but it's just enough to suggest how the animals ought to move. Here's a view of it from above. Same deal. You've got the kind of two arms of the funnel. You've got then kind of another blind out here. You have a rock to kind of divert the animals a little bit. There's a drop-off back here. And this is a really interesting rock in terms of something we heard talked about today. This once was standing upright, and it got pulled over by I think probably by a fishing net. And you can tell because you can actually see where it had been sitting. There's a depression that it had been sitting in, and then it was pulled over. So we can imagine, again, a big, tall piece here. Now, we know in Siberia, the caribou hunter, or the reindeer hunters, will not only create these inukshuks, but they'll actually hang ribbons from them that will sort of dangle in the wind. And it's because caribou, much like antelope, are very curious animals, and they're actually attracted to it. So you can imagine some of these constructions are actually attracting the animals into the area. But the other thing you'll notice, and I'm going to show you a short film of it, is there aren't any other rocks out here. So here you're going to dive on this site. That's the rock that fell over. That's an interior hunting blind. And there's the first line of rocks. Our ROV is hiding back there. Here's the second line of rocks that form the barrier. We often find a kind of backstock rock that's behind these structures, which is probably where additional hunters probably concealed themselves. And now you're going to kind of do a bit of a pan, and you're going to look back out there and look at all the other rocks that aren't there. Now, in a second. So there are the boulders that are forming that spaced line that goes off quite a distance that way. There's just not much more out there. This is another kind of complex one. This is drop 45. This is, again, this scanning sonar. And what you've got is you've got sort of a cobble pavement from the glaciers here, big open area, and then you've got these two lines here. And then you've got kind of a cul-de-sac back in here. So the animals would have come into this area and then gone through here. You've got hunting blinds in both of these spots. That's easier to see than the sonar image. But you can kind of see again how it's set up. That again, they're not going to any more work than they'd have to, right? They're taking advantage of this natural feature. They constructed this line. You have hunting blinds at both spots, and you have a natural cul-de-sac. Now, one of the interesting surprises to us was we also found two stone rings that are equivalent to small tent rings in these places, and this one had the remains of a central fireplace in it. So this was probably used temporarily after the kill and then abandoned again. Now, the other thing we've been able to do, because we're collecting all this environmental data, is we've decided to take advantage of our computing capabilities to simulate what this underwater world looked like when it was dry land. And we've started putting some of these pieces together. One of the things we've learned is that, first of all, they're complex and simple kinds of hunting structures. And these, it turns out, have seasonal implications. We've also discovered that there is something we call directional dependence, which is a lot of these hunting systems only work if the animals are moving in one direction. Now, since we know that caribou migrate in the fall and in the spring, and we know which direction they're moving, this actually lets us tell the season that a particular hunting structure is being used. And this is important because in these kinds of environments like you have here, animal bone doesn't survive. And so the normal indicator that an archaeologist would use of seasonality, which relates to tooth eruption on mandibles of the animals, you don't have. This is a way that we can get at seasonality, and it has really important implications for us. For one thing, as we've done the simulations, we've been able to show that the likely route that the animals migrated through was really different in the spring and in the fall. You get the sense that when they're moving this way, they're browsing. They're probably traveling slower. This is related to where we find those autumn hunting sites, which are scattered all over the place. And one of the interesting things about this is that this ridge is narrow enough that even a bad hunting site is still going to see animals passing by. This is the predictability that we're looking at. On the other hand, in the spring, these animals, and these herds are often led by cows with their calves, are just going to be gone. They're not waiting for anything. Now, when you look at these two maps, they look really different, but there's something they have in common. The animals always have to pass here. There's another spot down here where they always have to pass no matter what they're doing. Drop 45 is right there. So these hunters knew their animals, they knew their habits, they knew where they were going, and they built structures accordingly. So this is kind of what the annual round ends up looking like. In the fall, we have hunters coming out here. The animals are going to be moving south. And what we tend to see in these seasons are small family groups going out and basically hunting meat for the winter. This is also when the hides are at their best quality. It's when the sinew is best. But we don't find these big, complex hunting structures in the fall. We find mainly these smaller, simpler ones. And we find caching sites with them. And what they seem to be doing is in the winter, they're probably going back to the mainland because nobody in their right mind is going to spend the winter out here. But they're leaving food cached out here, which is frozen, which they can then access via sleds across the frozen ice. In the spring, people come back out here, and this is when the caribou, those large, complicated structures are being used. And what seems to be happening in the spring is people are aggregating, whereas you disperse before winter. In spring, people are coming out of the winter, they're hungry, the stores are depleted, and they're going to basically try to get as many animals as they can, but it's also not a great season for food storage. And so as a result, you have aggregations where you have many more people coming together. They're not caching the food, but they're sitting there and they're staying there a while with all these people. And you know, for hunter-gatherers, you don't get to do that very often. You don't get to have a conference very often. And so that's kind of how this is all being structured. And then in the summer is sort of a bit of a mystery, although we're starting to fill in the gaps now in terms of the other resources that people might be using out here, including fishing. I mentioned winter on the Alpena Amberley Ridge. This is a drawing that the people for National Geographic did of their interpretation of it. This is the Baldwin Peninsula in Alaska, which looks very similar to this. We took that picture in March. It's probably a pretty good analog for there, and that's probably why nobody in their right mind would stay out here in the winter. I mean, cold water on both sides. I don't think any sensible person would do that. Now, the other thing we've been able to do with this is because, again, we have all this data, we've created an immersive virtual world. So you can put on the goggles and you can actually traverse this landscape as it looked 10,000 years ago. And that's a pretty interesting thing to try to do, but we've taken it a step farther, and we asked traditional hunters to walk on this landscape and then to tell us what they're seeing, both in terms of why are the sites where they are, where should there be sites that we haven't looked. You know, we were really worried that these old guys would have real trouble, you know, doing this, and they did not have any trouble. They were right in there. They're recording their comments, you know, nonstop. And then one of them it actually was this guy, asked us if it would be possible to take anybody with him when he's there. And we said, well, probably. Why would you want to do that? And he said, well, I have a grandson, and I'd like to teach him about caribou hunting, but he only will play video games. So we said, well, okay, maybe this is a thing. And there's a spin-off that's now being developed where we're actually trying to use this as an educational tool, both in Alaska and also down here, to help students understand, this whole kind of process in prehistory. Now, the one elephant in the room that I haven't mentioned is I haven't really talked about artifacts, have I? The gold standard, right? Okay. Well, if you're in the Great Lakes region and actually much of North America, at this time period, this is what you're looking for: large fluted points, gainy points, high-low points. This is Paleo-Indian, early Archaic. This is kind of standard, almost continent wide. And unfortunately, again, since I don't have audio, you're not hearing this clever quote, but it's you humans, you think because something is small, it can't be very important. Frank the Pug. Anyway, here's the surprise. We don't find any fluted points. In fact, we don't find big bifaces at all. What we rather find is this kind of microlithic tool industry. These tools are very small. If you look at the scale bars here, these are very, very small tools. These are the kind of tools that actually, at the beginning of the Holocene, you find in many parts of the world other than North America. And that's why it's called the Mesolithic in Europe. These tools look very much like the Arctic small tool tradition you see in Alaska. And what's really interesting is they're either very, very small unifacial tools like this one, which is some kind of scraper, or they're blades which are then hafted into antler or bone to make composite tools. The other thing that's interesting about this from the point of view of evidence is this is beautiful honey-colored yellow chert. And the problem is if you break this open, it's gray. And the yellow color is formed by subaerial erosion. So as the water levels come back after this is abandoned, there's a period when these sites are very near the surface. They have pines and everything over them. It's a very acidic environment, and it turns them this bright honey color. I almost made a huge blunder and published that we found this new chert source. And Bill Fox, one of these Canadian archaeologists, said, nah, it's not real. Just break it open. But what's cool about that is that makes it clear that this flaking and this modification happened before this tool was subaerially exposed. So it's extra evidence that this is a very ancient tool. The other thing, this is a small thumbnail scraper. It's about the size of your thumbnail. It's important because it's made on an identifiable chert. It's made on Bayport chert, which outcrops about 100 miles south of where we are, which is important for us because the glacier couldn't have brought that stone there. People had to carry it up there. And you have one of these mini scrapers, and this is again, look at the 2 millimeters. That's tiny. And yet you've got edge damage, you've got some micro retouch here where they've modified it to fit into that haft, and where they've done microwear analysis where you can tell how a tool is used. Down here you get this back and forth wear, which suggests that it's moving in its haft as it's being used. So it's again, the clear evidence that this tool was mounted and that it was used. We've also started finding some other artifacts, and these artifacts begin to give us some hints about that other season, that summer season. So this is actually a grooved axe. It's sharpened on this side, and you can see where the groove is, where it was mounted. You're not supposed to find these until the late Archaic, which is like 3,000 years later. This is a net sinker. You find a series of these. Again, you minimally modified, a notch there, a notch there. And this is a chopper from up on Manitoulin Island. But you're not supposed to find net sinkers until the late Archaic either. And what we're beginning to see is that some of these innovations in terms of subsistence as you move into the Holocene in the Middle Archaic were happening about 2,000 years earlier, but they're happening out on land that's now underwater. As soon as the lake levels rise and the archaeological sites are found on the new lake levels, on the new lake shores, you find all these tools all over the place. But they just happen sooner and they're underwater. This is probably one of the most surprising finds we've had. These are 2 flakes of black obsidian, which is a kind of volcanic glass. And one of the really nice things about obsidian is you can source them very, very precisely using neutron activation. And in fact, these 2 flakes of obsidian, which were found out here in Lake Huron, came from the Wagon Tire site in Central Oregon, more than 4,000 miles away. These are the earliest obsidian finds that are in a known archaeological context, and this is certainly the most westerly occurrence of Wagon Tire obsidian anywhere. So this is pretty amazing. These guys moved, or at least were in a trade network that moved materials more than 4,000 kilometers, 10,000 years ago. Don't underestimate. This is actually the site where they occurred. Here's showing kind of where they are, and it's a really instructive landform. Here's a small esker, and then you've got this opening, and you've got hunting blinds kind of bracketing the opening from there. The obsidian was found right in the middle. So here again, here's a blow up, the end of the esker here. Here's the line. Here you've got that V cluster. You've got another V cluster. You've got another blind here. You've got that backstop. And the obsidian came from right there. And this is important because this means this obsidian isn't being used for ritual purposes. This isn't some kind of magic rock. This is a utilitarian item. These 2 flakes came off a biface that were being used to process caribou in this kill area. And that again tells us kind of how the perception is. In later times, for example, in Hopewell times and later, you get large quantities of Western obsidian being transported to the east. And it's used in some of the famous mounds and some of the burial sites. It's definitely a ritual object at that point. But 10,000 years ago, it was just a really, really nice raw material, and it was being used here. This is our explanation for maybe why this is happening. When people think about the end of the Ice Age and the ice withdrawing, people normally think about people moving from south to north. People gradually occupying land as the ice withdraws, and as the Holocene sort of makes it warmer and nicer. Deer replace caribou, oak replaces spruce, this kind of thing. But there's a second axis of movement, and that's along this recently deglaciated ice front. Now, despite what you might think, this is actually a very, very rich environment. This is an environment that caribou would have been attracted to. And what we suspect is happening is that you're getting an adaptation to this ice front, this withdrawing ice front, that's kind of gradually moving north. In British Columbia now, they've found similar microlithic tools as ours on a series of sites at the same age at about 9,500 years ago. So this is something that's going on along this ice front. And the irony of this, from my perspective, is that what we're seeing in Lake Huron may be the very last of it rather than the first of it. And presumably our people, are the people that are building our things, are moving north with the ice, even as the Southerners start moving up and colonizing Michigan with their Kirk Points and what have you. So what we end up finding, and I'm not patting myself on the back here, it's rather the process of discovery, really, is that there's something that's just never been seen before. It's got these hunting structures. None of them are known in the Great Lakes region. This microlithic tool industry, completely unknown here. Composite tools, precocious things, this long-distance trade, all of this is completely unknown in this region. And yet, there's the evidence for it. But what it does have is really great similarities to small tool industries in the Arctic. And we suspect that the reason for this similarity isn't necessarily that we're dealing with a single people, but we're dealing with a technology that's very well suited to this kind of recently deglaciated environment. Now, what would a recently deglaciated environment look like? Well, we know it's going to be flat. We know it's going to have really immature drainage systems. There's going to be a lot of water around. we're probably not going to have really good chert sources for raw material. We're going to get glacial cobbles. We're going to get people scavenging chert nodules out of the glacial till to make their tools. And these nodules set a natural size limit on how big the tools could be. And they're moving, and because they're moving, there's always an element of uncertainty about the environment, about the availability of raw resources. So you could ask, why do we only find this underwater? Doesn't that seem kind of weird? I mean, people have been doing archaeology on Paleo-Indians in this region for 150 years. How come it hasn't been seen before? And I think the reasons are, first of all, that things are preserved out here that aren't preserved anywhere else. We heard a talk this afternoon about trees, wood that's preserved in the tidal zone that's 1,500 years old. We have still-rooted trees that are 10,000 years old, that are preserved in the water, in the fresh water. The other advantage we have is that we have a narrow chronological window. This land is only really available for people to live in for about a 3,000-year period. Now, I know to you guys working in the colonial period, that isn't a narrow window, but for us, that's a pretty narrow window. But what it means is anything we find there, nothing can be younger than 7,500 years old. Nothing can be older than 10,000 years old. It's because that's the only time this is dry land that's available for use. So what this lets us do is we don't have to make arguments of relevance. If it's there, it had to fall within that time span. Now we are able to do carbon dating. We've carbon dated charcoal from fire rings and different kinds of structures. We've carbon dated some of our trees. So we've confirmed the kind of age times that we're dealing with, but we don't have to worry about really new things or really old things screwing us up. And the other thing that makes a difference for us is underwater, we're necessarily using very fine-grained kinds of recovery. I mean, we're collecting sediment from the bottom. We collect about 1/10 of what a normal survey would do, not just an open excavation, but a survey on land. But yet everything that we do is sorted under fine screens with magnification, with good light. So we're actually finding things that the average archaeologist doing a quick survey on land isn't going to find necessarily, because we don't have those big bifaces. Why now? Well, we have the technology. If we didn't have GIS, if we didn't have GPS, we couldn't do any of this. We couldn't get back to the same place as precisely as we do now. A lot of the technology that we use for underwater research has gotten miniaturized, which means we can deploy it off smaller boats, and it's gotten less expensive. And we have this ability to do artificial intelligence and modeling to be predictive, so we can do more precise in our work. We also have this global comparative perspective. We have a lot of examples to look back to and say, okay, well, how did they solve this problem in the Arctic? How did they solve this problem in Siberia? And I think the single biggest thing, and this is something that I think is relevant to your organization as well, is this idea of sustained research, that you can't go out in a year and do this work. You know, it's taken us 12 years to get where we are, and the lake gives its evidence very grudgingly. We have 2 obsidian flakes. We have 1 caribou tooth, you know, so you can't be a tourist, you know, you gotta commit to the long term, and I think the efforts that you guys are making in documenting your structures up here is probably the same kind of thing. You couldn't just do it in 1 year or expect to have it done. Well, that's my story. These are some of our sponsors, and I'd be happy to take any questions you might have. Yeah.
What's the temperature down at the bottom?
Depending on the season, it's 38 to about 42 degrees Fahrenheit. So it's cold, but it's definitely dry suit diving.
How long is the ascension?
How long is the ascension? It's basically, we surface at about 15 feet a minute. I mean, we try to do it pretty slowly. For those of you who dive, we're using mixed gas anyway. We're not doing decompression diving, but we do that stage thing. And one of the reasons we use mixed gas is to try to be able to turn around our dives quicker. So we're 60 miles offshore. So it takes us a good hour, sometimes an hour and a half to get on site. So we try to roll as many pairs of divers as we can in a trip.
One more.
Yeah.
About how much longer would it take you to investigate a site like that underwater as opposed to on land?
So the question is, how much longer would it take to investigate one of these underwater sites as it would one on land? Well, if you figure that each time we visit one of these sites, we've got a half an hour. That kind of plugs it in to how efficiently you have to work. The thing that gives us an advantage, the thing that makes it practical, is most of the time we're testing near constructions. So it's not like we're randomly surveying like an archaeologist would in a farm field. Because we're sampling near constructions, we have a much higher than likely chance of encountering material. And in fact, we've done some studies where we've compared the density of finds in our excavations as opposed to other ones like in the Arctic. And we actually have a higher return rate, although they're very small, even though we're taking small samples, just because we know kind of what we're targeting. It'd be like sampling around a building or in a building as opposed to out in the field somewhere. Yes, ma'am.
What was the geography of the rest of the lake? You said when you look for rocks out there, you don't need the structure you have, and it's really nothing there. Is it possible that they had to drag those rocks, or is there other areas out there that just have abundance of rocks and they move only a short distance, and they have to drag them across that ground area to get someplace up?
So the Alpina Amberley, Michigan is a basin, right? So the rocks kind of come up like this, and the Alpina Amberley Ridge is actually an edge of the Traverse Formation. So what we have jutting strata of limestone, basically. And as that juts out and it undercuts, it breaks off. So there are areas, some areas, I mean, there's an area out here on the old charts, it was called 6 Fathom Shoal, which is 36 feet. And in fact, it's only 40, it's actually 40 feet. But so you have a lot of topography, and wherever those limestone strata break, you get a lot of raw material. And then you also have boulder fields, which is just where the glaciers have dropped rocks. So in a lot of cases, what we see people doing is they're just kind of selectively moving things together, or in some cases, again, taking stuff away to create an open path. Now, with those old red sandstone, they probably went to some effort to do that, I think. Because they're big boulders and they're not the most common stone that's out there. So they were capable of doing this. We don't find large multi-rock constructions, but although we do find two-level stacked stones. Does that answer your question? Yeah, because it's on the ridge. They're not going to take it through that 500-foot deep thing and then back. Right. So that area, that's an area, that bedrock there is limestone. And you're at a relatively high elevation there. That's only about 70 feet deep. So that's pretty much the top of the formation, and then it falls away. So what they were doing to construct that is right where the strata were falling off. Even right in that vicinity, they were pulling them up and positioning them. But they weren't having to take them in a long distance. But when you look out over that flat plain, there aren't any other rocks sitting out there. And that is both, a testament to what the natural environment is, but it's also telling you that the rocks that are out there were put there on purpose.
Hey, on the swim shop, can you hear me?
Yeah, I can hear.
So there's a part of it that looks slightly ceremonial, but in this period, there are a lot of images on that look almost like a scene, the smaller ones working on something in the corner and some action shots. I haven't seen any kind of motion like that or representative kind of a family village like ever from this period. So please explain.
Okay, well, so that pipe isn't from this period, right? That's the first step. That pipe was probably created in the late 19th century. But what's really cool about that pipe is that on all the sides of it, it shows every subsistence activity that village conducted. So there's a scene of fishing, there's a scene of meat storage, there's a scene of the caribou hunt, and it goes all the way around the circumference of that pipe. But no, that pipe's 19th century. Other questions? Okay, well, thank you. And again, thanks for the invitation.
Good job.